Good morning. This is lesson 3.1 and 3.2 on functions and linear functions. To start off, let's start with this warm-up that talks about standard form. The PTA sold tickets to a football game. Adult tickets are $10 each and student tickets are $5 each. The PTA collected a total of $550. So please pause your video and see if you can figure out what the equation would be in standard form and identify the x and the y intercepts. Okay, so the first thing we want to do is we want to identify what is our x and our y variables. So what's being compared in this problem? We're talking about adult tickets and student tickets. And I like to go in order of the problem. So since adult tickets appears first, I'm going to make the x our adult tickets. And I'm going to make our student tickets y. Okay. Now, when it comes to the equation, we need to really look at the words that are in our equation. So we know that adult tickets are $10 each, okay? The word each tells me that I'm going to multiply. So since I don't know how many tickets were sold, I'm going to write that as $10 per ticket or each, so 10x, okay? The word and tells me I need to add, so I'm going to add my adult plus my student tickets. Okay, student tickets are $5 each. So again, I see that each word tells me to multiply. And since students is represented by y, I'm going to have 5y. Then I see the word total. Total tells me that's going to be the combined efforts of these two. So it's going to be equals, and it's equal to $550. Okay, so we need to identify the x and the y intercepts. So if you remember from our class, we did the cover-up method. So I took a square or a shape or whatever it would be. You can use your finger if you want to. You can cover up your x variable. Okay, so if I make my x 0, that will cancel out. And I have to solve to figure out what my y would be. So if I take 550 and divide it by 5, I get 110. Okay, then to find my other intercept, I'm going to move my box over, move my finger over, and cover my y. So this time my y value is 0, and I'm trying to find my x variable, my x value. So 550 divided by 10 gives me 55. All right, so this problem didn't ask for it, but you need to understand what these two things represent. These x and y intercepts in this problem, they measure the extremes. So since X stands for adult tickets, if I buy no adult tickets, I could buy 110 student tickets. Okay, and the other one is the opposite. If I buy no student tickets, I can buy 55 adult tickets. Now, obviously there are points in between. You can have a combination of adult and student tickets, but these ones just measure those two extremes. Okay, so this lesson is actually two lessons combined into one. The first one is 3.1 relations and functions. This part is review from 7th grade. And then 3.2 is some of the newer things. So I am going to go a little fast with this, but feel free to pause, rewind, anything you need for this, and reach out to me if you still have questions or are confused. Okay, so first we need to know what these two words mean. So a relation is a set of ordered pairs. So the word relation is kind of like relationship. It's comparing the x values to the y values. So when x is 1, y is 11, x is 2, y is 12, and so on. So this is an example of a relation. It is not always written in order pairs. It could also be written as a table. Okay, a function is a relation where each input or x value has exactly one output or y value. Okay, so for this one, you see here are all of our x values. Here's all our y values. Every x goes to its own y. Now, I know some of you are probably looking at these 13s and you're saying, well, these three x's go to the same y. That is okay. All right, here is my general rule of thumb. I'm going to type it here. No repeating x's. Okay, and I like to put it in terms of relationships since we're talking about relations and functions. Okay, when you have an ex-girlfriend or an ex-boyfriend, okay, you don't want to go back to them. You're not going to repeat history. Okay, if you go back to your x's, bad things are going to happen. They're an x for a reason. So we don't want any of our x values in our functions to repeat. So see how every x value, 1, 2, 3, 4, 5, they are unique. Okay, we don't care if the y's repeat, that's fine. But we do not want to repeat our x's. Okay, so let's see if these are functions or not. So looking at this first table, I notice there are no repeating x's. So this one is a function. So I'm just going to write yes on the line. Okay, no repeating x's are a good thing. All right, what about table 2? No repeating x's, so it is also a function. Uh-oh. Over here, I have a 4 and another 4, so this one is not a function. Okay, sometimes they show it to us as ordered pairs. Okay, same thing, no repeating x's. So if you look at just the x values that you see, we have 6, 4, 6, and 2. So you see you have 2 6s. Repeating x's are not allowed. Okay, what about over here? 5, 3, -2, and 0. They are all unique. They're all different. So this one is a function. Okay. Then there's a couple other representations you may see. So sometimes you may see it on a graph, right? Hopefully you remember from last year, we have a certain test that we can do that will tell us whether this is a function or not. Okay, it's called the vertical line test. So I'm going to go ahead and draw a vertical line. It's a fairly thick vertical line. But if I take my vertical line and I slide it left to right, I am only allowed to hit 1 point at a time. So if I put it here, I just hit 1 point, 1 point, 1 point, just 1 point, and 1 point. So this first graph have no dots that are stacked on top of each other. So they don't have matching x values. There's no repeating x's. So this one is a function. So we can say yes. Okay, it passes the vertical line test. Now, if I take my same vertical line and I bring it over here to this sideways parabola, okay, you will see no matter where I put it, except for at the very end, if I put it here, it's actually going to hit twice. Okay, so it hits right there, it crosses, and it crosses there. They are above each other, so that means that the x values are the same. This is not a function. Okay, so it has to pass the vertical line test in order to be considered a function. And then one other way you may see it, these are called mapping, okay? And the way mappings work is it's listed in order from, well, sometimes it's listed in order, sometimes it's not. But you have matching pairs. These are actually ordered pairs, even though it's in a graph form or in like a table form. Okay, so -2, 1 is an ordered pair, 1, 2 is a pair, and so on. Now, the rule with these ones is you can't have 2 lines coming from the same x. So see how every x has one single line coming from it? That means that this is a function. Now over here, see how the 5 has 2 lines going to it and the -3 has 2 lines going to it. So this one is not a function. All right, if you are unsure with these ones, you can absolutely write them out as ordered pairs and look at the x values like we did earlier on this page. Okay, now we need to talk about domain and range. And again, this is also a review from last year. Domain is a set of all of our inputs or all of our x values. Range is all of our y values or our outputs. The way I remember this is domain and range. If we look at D and R, in the alphabet, D comes before R. Well, so does X. X comes before Y. So domain and X's go together, range and Y's go together. Okay, so I have some examples here. One is a table and one is ordered pairs. We're going to identify the domain and the range for both of these. Okay, so when we're listing our domains and our ranges, we want to order them from least to greatest. So if I'm looking at this table, I want my domain or all my x values. It looks like they are already in order. So what I can do is I'm just going to put a little bracket here and I can list in order my x values. 1, 2, 3, 4, and 5. Okay, sorry, my brackets are a little funky. All right, my range, I'm going to list my outputs. So I have 11 is my smallest, then 12, then 13. I do not have to list repeats. Okay, I just want a list of what are all my possible X and Y values. So even though there are 3 13s there, I only have to list 13 once. Okay, and same thing with my ordered pairs. I'm just gonna look at my domain, I'm gonna look at my X values, and I'm gonna go from least to greatest. So it looks like 0 is my smallest, 2, 3, then 4. Okay, and my range, I have 4, 7, 9, and 8. So 4, 7, 8, and 9. Okay, all the possible X's, all the possible Y's. Okay, we also have to think about what domains and ranges are reasonable. Okay, so in some cases, we can have decimals and fractions and parts of wholes. In some situations, it doesn't make sense to have that. You have to think, what is your maximum value for your inputs and your outputs? So in our first example, a hose fills a 10,000-gallon swimming pool at a rate of 10 gallons per minute. So I see that per minute. So that tells me the minutes are my input, what we're putting in. Okay, so think about time. How much time is it going to take to fill the swimming pool? Well, we can go from 0 minutes to however long it takes to fill the pool. We're not sure what that is. Okay. Now, when it comes to the gallons or output, the smallest amount of gallons we can have is 0. We wouldn't have negative gallons. And then our maximum would be our 10,000 gallons. We don't want to overfill our pool. So in this case, let me pull this down here. A reasonable domain is from 0 minutes to the time it takes to fill the pool, and the reasonable range is from 0 to 10,000 gallons. Now, in this case, it does make sense to have, you can have part of a minute. You could have 30 seconds, which is half of a minute. You could have part of a gallon. So in this example, and we're going to talk about it again in a minute, fractions and decimals and parts of wholes are okay. Okay, now in the second example, a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So this one, we have tables and chairs. I'm just going to show you this one. A reasonable domain is from 0 tables to the number of tables needed, because we're not sure how many tables will fill this restaurant. It all depends. But you can order 0 tables and you can order however many it'll fill. And a reasonable range is multiples of 4, because you need to fill a table. You wouldn't have one table with just 2 chairs or a table with 3 chairs. It has to be multiples of 4. And that will also depend on how many tables are needed. Okay, now in this example, it does not make sense to have decimals and fractions. You wouldn't order part of a chair or part of a table. So these ones are not going to have decimals and fractions. So that kind of leads into our next one. Okay, discrete. Discrete and continuous. Discrete data, the domain includes whole numbers and integers. They're individual points. Continuous data, the domain, can't talk today, includes all real numbers, which are lines and curves. That includes everything in between, decimals and fractions included. So the way I like to think about this, and let me show you the 2 graphs. These are the graphs from the previous problem, our pool and our tables and chairs. This is a continuous example because I can take my pencil and I can draw this line without picking up my pencil. So lines and curves are continuous. They don't stop. Okay. Discrete data are individual points. You have to pick up your pencil every single time you want to plot these points. So this one does not include those parts in between the holes, whereas the pool one does. Okay. So in this case, we want to analyze a reasonable domain and range for each one of these. So go ahead and pause your video and see if you can come up with an idea of what you think an appropriate domain and appropriate range would be for these ones. All right, so for the first one, a bowler pays $2.75 per game. So when it comes to our domain, our input is number of games. Okay, so they can play 0 games to however many games they want to play, right? So we don't really have an end. So I'm just going to put infinity because it could keep on going. They wouldn't play infinity games, but however many games they want to play. Our range is the money. What's the smallest amount of money you could play or pay? Well, if you play 0 games, you're going to spend $0. Okay. And our highest point is also infinity, but it's going to be multiples of 275, right? Because that's how much each game would be. So it has to be increasing by 275 every single time. Okay, so a car travels 25 miles using 1 gallon of gas. Okay, so that's per gallon. So our domain is our number of gallons. We can have, it says car travels 25 using 1 gallon of gas. So you can have 0 gallons of gas you're using up to 1 gallon. And our range, they travel 25 miles. You can go from 0 to 25 miles. Okay, so think about what's reasonable. In this case, our bowler, we would be discrete data. You cannot spend money that is in between 275s. You wouldn't play part of a game. Okay, they're still going to charge you whether you play half a game or a whole game. This one over here, we can have part of a gallon. We can have part of a mile. So this would be our continuous data. All right, here's a bonus question. So this one, we want to tell what the domain and the range is and whether it is a function or a relation. So domain is all of our available x values. So what I'm going to do is I'm going to start here on the left because this is my smaller x's, and I'm going to list every x value that has a dot above or below it. So in our first one, we have, there's a dot here and its x value is -4. Okay, then I move over. -2 has 2 dots, but we only have to write it once. Okay, then -1 has a dot. Oops. Okay, and then my next one is 3 has 2 dots, but again, we only have to write it once. Those are the x values of the dots that we see on the graph. Now we're going to do the same thing with a range. This time we're going to look at our y-axis. So my lowest y is -2, has 2 dots. 0 has a dot. 1 has 2 dots. And +2 has 1 dot. All right, so now looking at our function. Is this a function? Well, if you're looking at just this part here, it looks like it is. But we have to do that vertical line test. So remember, if we draw a vertical line, if I draw it right here, it hits 2 dots. If I hit right here, it also hits 2 dots. So as soon as it hits more than 1 dot and you have dots stacked on top of each other like this, it is not a function. It failed the vertical line test. Now, is this a relation? Yes. We are still showing the relationship between our x's and our y's. So sometimes it could be a relation, but it is not a function. Okay, so now we're getting into 3.2. This is the part that is more new and may not necessarily be reviewed from last year. Function notation. So I have this function machine here. Our input or our x value, our domain is going into the machine, and then our output or our y value is coming out of the machine. Now they have called this f of x. F of the x is the same thing as y. Okay, so whenever you see f of x, I want you to think of y. So sometimes they may say this is the function f of x equals 5x plus 1, and sometimes they say y equals 5x plus 1. These two things mean the exact same thing. Okay, this first one is written in function notation. And the way we say is f of whatever's inside. Okay, so remember your domain goes in, your range comes out. Okay, so sometimes you may have to evaluate functions. So I'm going to show you one, and then I'm going to give you a chance to try some on your own. All right, these are fairly easy. So they give us the function here in function notation, f of x equals 4 times x plus 2. And then this tells us what they want us to do. Find f of 8. So in this f section, the x is replaced with an 8. And I'm also going to replace my x on the other side with 8. Anytime I see an x, it's going to be replaced with 8. So please note, this f of 8 is just the name of the function. We are not doing anything with that. That just comes down. Okay, just along for the ride. It's the name of the function. This is the side that we're going to simplify. 4 times 8, well, that's 32 plus 2. So f of 8 is actually equal to 34. So you should get a number answer for what f of 8 is equal to. Okay, go ahead and pause your video and see if you can try the next 3. Okay, so this one here, they tell us they want h of -9. So I'm going to go ahead and substitute that into the name of the function. Okay, and then I'm also going to substitute my x is going to become -9. All right, so remember, this is just the name. I'm going to bring it down. Well, 4 times -9, that is -36 minus 2. So if I'm at -36 on a number line, I have to move 2 spaces to the left. I'm now at -38. So -38 is the value when h equals h of -9. All right, over here, I'm going to substitute 3. Okay, my name is f of 3. 4 times 3 is 12, plus 1, I get 13 is my answer. All right, this one is going to be g of -2. And let's go ahead and bring our name down. 3 times -2 is -6, minus 5 gives me -11. So how did you guys do? I'll tell you, one of the most common mistakes is people try to get rid of the h of whatever on one side. It simply is a name, so it just comes along for the ride. Okay, caution. So these are different things. This one says find the value of x when h of x equals 0, and they give us this function. Okay, and sometimes they change the letters in the front just so you can identify different functions if they have more than one. H of x equals 0 is not the same as h of 0. Okay, this is what we were doing on the last screen. This one says h of x equals 0. Well, h of x is this part right here. So that means I have to substitute 0 in for this side of the equation. So I would have 0 equals 2x plus 3, and I would be solving for x. Okay, it is not being substituted in for here. The only time you would substitute in for both x's is if it looks like this. All right, so this one, if I solve for x, I would subtract 3 from both sides. And if I divide both sides by 2, I get x equals -3/2. Okay, so this one is not the same. So be careful. H of x, remember that's the y. It just goes into this side of the equation, whereas when it looks like this, it goes in for both. All right, so sometimes they give you a function table and they want you to come up with the equation. This is very similar to what we did in our last unit when we were talking about linear equations. So this one, it has the cost of making 4 bracelets shown in the table, and we want to figure out the cost to make any number of bracelets. So we want to come up with a value. So the first thing we want to do is we want to look at the relationship here. We want to figure out what is the rate of change or the slope. So I'm going to show you some symbols here that kind of represent slope. Okay, this, when I put a triangle, that means the change in y. So what we're going to do is we're going to do the change in y over, sorry, I lost my mouse, over the change in x. So this is the same thing as that y2 minus y1, x2 minus x1. So you can view these on the table, you can view them as ordered pairs. 117 is an ordered pair, 232, and so on. Okay? Or you can think of it as a change in y over the change in x. All right, the change in y. So each time to get from 17 to 32, 32 to 47 and everything, how many am I increasing every single time? All right, so you can subtract. So for example, if I do 32 minus 17, I can tell I am increasing every single time from here to here, here to here, and I can test them all out. I'm increasing by 15. So my change in y is, 15. Sorry, I ended up losing my mouse and can't write today. let's try to rewrite that for you real quick. All right. And my change in my x, so how much is it increasing by every single time? Well, I can see it's counting by ones. So in each one of these, we're adding 1. So my denominator for my change would be 1. So 15 divided by 1 is 15. That is my slope. Okay, so that is my m. All right, so now we need to figure out our b, because in part 2, it's asking us to write it in slope-intercept form. So to find the y-intercept, we get to pick any point we would like. So you can choose 117, 232, 347, whatever point you like. I'm going to choose 117. So if I substitute my m into that and those points, remember this is my x value on top, and this is my y. So I can say, let me change my color here so you guys can see it. I can say my y value is 17. My m value was 15. Sorry, that's an equal sign there. Let's see if I can erase a little bit. All right. $17 equals 15. My slope is, sorry, my x value is 1 plus b, and I'm solving for b. 15 times 1, well, that gives me 15. So I end up with 17 equals 15 plus b. If I subtract 15 from both sides, I get 2 equals b. Well, now I know what my m is and I know what my b is. Now I can go over here and I can write my slope-intercept form. I can say y equals 15x plus 2. Okay? All right, so that tells me that the number of bracelets per cost per bracelet is increasing by 15. All right, so I would like you guys to pause your video and see if you can come up with the equations for these two functions. All right, so for the first one, my change in my y over my change in my x. To get from 6.5 to 13, if we do 13 minus 6.5, we get 6.5. Okay, and then it's increasing by 1 every time, so my slope for the first one is 6.5. All right, you get to choose whatever point you like. I try to avoid the decimals if I can. I'm going to use this 213. So I'm going to say 13 equals 6.5 times 2 plus b. Well, 6.5 times 2, that gives me 13. If I subtract 13 from both sides, I get b equals 0. So there is no y-intercept. So this equation would be y equals 6.5x. You don't have to put the plus 0 at the end. Okay, this one over here, my change in my y over my change in my x. So each time I'm adding 3. And on the top, I'm adding 1. So my slope is 3. Make sure you're doing y over x. Okay, I can pick any point I want. I'm going to choose 2, 4. So I have 4 equals my slope times my x plus b. 3 times 2 is 6. And this will also work with whatever point you choose. So I'm going to go through quick, and I get -2 as my b value. So this equation would be y equals the slope of 3x and an intercept of -2. Okay, so basically you're using your point slope form just like we did in the last one. Okay, all right, sometimes you're presented with word problems, and we are going to do some more word problems in tomorrow's class, but I want to show you one of them. Okay, so this one says Tamika records the outside temperature at 6 a.m. And we see the recording here is -3 degrees Fahrenheit. The outside temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the rate be at 2 p.m.? So we want to first write an equation that represents this. Okay, so I can either say y equals, or I can say f of x equals, because we want to write it in function notation. Okay, so we got to think, what is my slope? What's my rate of change? Well, it tells us here and here that it's increasing 2 degrees every hour. So 2 degrees per hour. Okay, now our intercept is, what is our starting temperature? Well, at 6 a.m., she went outside and she saw that it was -3. So that is my intercept, my start point. Okay, so this is our function. On the next screen, it's asking us to sketch a graph of this. Remember, even though it is in function notation, this is the same thing as y equals 2x minus 3. We can graph this. My intercept is -3, and my slope is 2. So I'm going to rise 2. Sorry, this one doesn't have a -1 there, but -2, -1, and I'm going to run 1. Rise 2, run 1. I can do that as many times as I want, and then I should be able to graph my line. Okay, so it's just like y equals, even though it says f of x. It's in function notation. So then the last step says find the value of when y equals 8. So remember, it was 2 degrees per hour. So what this is asking us is, after 8 hours, what would the temperature be? So we can evaluate this by substituting 8 in for x. So we want to figure out, whoops, my pen. They want to figure out what is f of 8. Okay, remember, f of 8 is just the name. Whoops, let me bring 8 down. 2 times 8 is 16. 16 minus 3 gives me 13. So that tells me 8 hours later, which I believe was 2 p.m., our temperature was 13 degrees Fahrenheit. Okay, so you have a couple steps to do to figure out these word problems. Don't worry about these too much today, because we are going to practice them tomorrow before we take our first formative that is on function notation and different kinds of functions. So there is an exit ticket on Schoology. This one is a little bit longer because I want to make sure that you guys are good with relations, functions, and how to evaluate and write in function notation. If you have any questions, I am available in our virtual classroom, or you can send me a message on Schoology or through email.